Welcome to the NewSpace India podcast, a bi weekly talk show that exclusively captures insightful conversations with people contributing to advancement of space activities in India. The NewSpace India podcast is pleased to announce our association with Dassault Systems, a global leader in providing business and people with collaborative virtual environments to imagine sustainable innovations. Dassault Systems solutions support startups, small and medium-sized enterprises, and original equipment manufacturers in developing disruptive solutions for space launches and satellite propulsion. Recently, a supply chain digitization study with Dassault Systems was conducted to provide a foundational understanding of the supplier landscape in the Indian space ecosystem. Please use the link in the description to download the public white paper of the results of this study, which will also give you a perspective on how ready Indian suppliers are to enter the global space market. Hi, and welcome to the NewSpace India podcast. And today we have Nitish, who's the CEO of Astrogate Labs, here with us to talk to us about their technology development with optical communications and how they would like to enter the space industry as an Indian company serving the world. Welcome to the show, Nitish.
Thank you. Thanks, NP, for having me. It's always a pleasure talking to you.
Great. So I know Astrogate Labs for the last few years, and you've been quietly working away in developing the technology that you are, which is very fascinating, and probably the first time in India that somebody is trying to put together this suite of technology as an Indian company, or even I don't think there's even an effort within ISRO in what you're trying to do. So before we talk about Astrogate itself, can you talk a little bit about your own background and what got you into space and how Astrogate then began?
Yeah, sure. So the passion for space was always present. Till now, I have been in the space industry now for 7.5 years. Graduated from IIT Kharagpur in aerospace engineering with both a bachelor's as well as a master's. During my third year, roughly around I think 2012, that's where I came to know much more about what's happening on the space one sector, and I was closely following X Prize Foundation. That's when the time I learned about the Google Lunar X Prize, and also came to know that there's a Indian team competing in that, and that seems much more a fascinating opportunity for me. Uh, Early during that time, I did certain internships with them, which actually gave me a much more detailed overview of the whole aerospace systems, how to build the systems out. After I graduated 2014, I decided to join them because that was my calling. I worked there for almost 3.5 years, started early where my role was on mission trajectory design and orbit estimation. Later on, I was handling the whole mission planning and operations team, which was dealing with one aspect of that was obviously the launch side, provisioning the launch for our mission as well, and the other side was developing, the mission operation software, testing that out, as well as you need the ground stations for us. What we were doing is for lunar communication, the only ground station sort of that was accessible for our data rates was either the NASA Deep Space Network, the European Deep Space ground stations, or the ISRO IDSN. So that's actually got me into much more on the satellite communication area. Learned what the challenges was there. My co-founder Aditya is also an XTI employee. He is mostly on the mechanical engineering and thermal development side. We bounced this idea to and fro within ourselves, came with a proposal, and right early on, somewhere around mid 2017, decided to look at it from an external perspective. So, what's happening on the communication side? With our connects that was established across the space sector, with mentors who was very helpful to provide us quick answers and know-how of what these systems are doing and what the challenges are. We were able to draft a plan out to start doing the optical communication side and how to build about the product portfolio that we want to do. So that's how we roughly came about being.
Right. And When you started all of these things, how was the journey? Because I'm sure that you did some research to know that there's perhaps nobody in India trying to build what you were planning to build, right?
Right. So when we started venturing into this optical communication space, one of the things we checked was what were the systems that are available, and obviously the precursor to that is what is the exact challenges on the communication one side. So we see that obviously the optical communication development has been there for more than 20-25 years, but the major bottleneck that we felt was the lack of availability of product, which was more suited to the small satellite category. And at that time also there was not many heritage terminal within the space. As of now also that's the case. The bigger satellite terminals, if we talk about ASAT and all, they have already well established terminals. Those are for bigger classes of satellite. Where we see right now small satellite as the basic medium for any private companies that are venturing out into satellite application, whether it is Earth observation or information satellites or even certain technology demonstrations or communication, and then the communications area. So we started exploring with our mentors. And one of the key things we realized is even though certain systems, optical communication that was to be, I'm in the process of the build out, and this I'm talking about globally. I'll come to the India part also. So globally, when we saw that one was the basic challenges of optical communications, however counterintuitive it sounds. It's not communication in itself, because if you look at terrestrial fiber optic communications, it's almost the same sort of technology. Only the problem is we are not using the optical fiber as a medium to communicate here. It's just free space that adds more challenges in terms to accurately point the beam and how does it acquire that. The major challenges we felt was the small satellite itself, their attitude, um, capabilities in terms of pointing as well as attitude knowledge was very much limited. And the systems that was being built, almost in every case, it requires certain tuning on the attitude estimation systems, and on the control system also, where you have to swap for very stable high reaction wheels to do that. And we wanted to make a product which is readily fitted into any satellite that comes out. So we jot down all those specifications that we wanted. On the India one side, we saw that there was an opportunity, obviously, to develop this system out from here, and that gave us one more opportunity to actually indigenize much of the system. So early on, during the year, we also took the call that we'll mostly want to indigenize the system out. Started with subsystems technology in primarily the pointing technology that we wanted. Then we started to do early test on that, and then finally the communication system. By the end of 2018, we were able to put together a quick prototype that we tested for multiple long distances in a static sense, where on the terrestrial one side, and then finally started doing certain quad rotor tests as well. So in India, I think the major challenges for us for starting was because we were starting mostly from scratch. We had to develop the whole tech stack. So that took quite a bit of time, but I think that was the right way to do it, because there were certain systems that required much more maturity.
Right, and for the benefit of the listeners, I think what would be also interesting to hear from you is, why optical communications? Because I do understand that there are some advantages when it comes to optical communications against traditional RF technology or other, means in that sense. So I think for
Right.
the benefit of the listeners, it will be also interesting for you to talk about, what are the drawbacks of RF communications and what is the benefit of optical, and then maybe even some disadvantages of optical where RF fills those gaps, and how that technology actually makes sense in today's world in terms of applications as well.
Right. So one of the key things is if you look about RF communications, it's not very scalable. If you want very high bandwidths or want to communicate at longer distances, almost certainly you have to increase the power and deploy. On the receiver side, you have to have a much wider receiver aperture there. So that increases the cost on both the sides. If let's say you're doing satellite to ground communication, you need bigger ground antennas here to support that, which increases the whole cost of provisioning this link. The other challenges on the satellite one side is because this whole mass is increased, uh, uh, and the power requirements on the satellite side is increased. If we have to replace it with a more efficient way of communication, laser communication is the way to go. But having said that, I'm not saying that laser communication can replace totally RF communication. There are certain areas that RF currently excels, specifically when you want to do point to multi-point communication. Those sort of links will not be replaced. Talking from a satellite application perspective, let's say talk about the low cost global broadband satellites that are coming up. In that case, the user terminal to the satellite one side will always primarily remain on RF. But where terminals can be replaced and will provide additional cost benefit is on the satellite to satellite communication side. Similarly, if you talk about satellite to ground communication scenarios, there are applications where uh, you have a very high amount of data that needs to be downlinked from the satellite, and in order to do that over let's say a day, it will be, you have to provision multiple RF ground stations just do that. So it it reduces that overhead in a small form factor, which reduces power and cost, and in turn totally reduces the cost. That's what the opportunities in RF are. Sorry, the opportunities in optical communications are. Also, the other advantage is optical communications as such is unlicensed band. One of the reasons that satellites or ground station need to pay spectrum licensing fees is because RF beam is always very broad. So, and owing to the limited number of frequency slots that are there, it's possible that the other satellite might not be used it within that vicinity. So that's always required to pay a spectrum license on the RF side, and optical side just bypasses that. It's a very narrow, dedicated beam. You save a lot of power. Inherently, you save on the total mass of the terminal, uh, and then finally saved on the total cost of provisioning.
Excellent. And one of the challenges in optical communication technology is also in terms of how do you miniaturize and also keep the high data rates that are possible in that sense. So
Yeah,
traditionally, I know that there's a lot of experiments being done for the last 20 years, maybe in optical communications to make it happen, but they have always been in larger systems with, bigger optics and bigger stations maybe and so on. So what is the challenge in, making a miniaturized or even a smaller optical communication system, and what kind of data rates do you think you can achieve in different sizes of satellites at different power levels?
right. So, yeah, one of the major challenges which really makes it very constrained to put it in a small form factor is the pointing constraint itself. So, I will draw the parallel from starting from a higher class of satellite. If you look at higher terminals which are right now operational, they employ something sort of a four-stage to five-stage precision control mechanism. So the amount of components, the control actuators, and the estimators much increases for that. The cost also increases by that. If we have to do that for a smaller satellite, that's not the way to go. So certain developments that has happened is what they have done is uh, just put the optics side of it, and almost all of the pointing constraint has been put on the satellite. So if the satellite can roughly do around zero point 0.1 degrees and all, then you will be able to achieve the data rates that you are expecting. So, but we felt that that's not the way to go, because then you are actually asking for additional development on the size of the satellites, and this will not be readily deployable. So we decided to see this and split the requirements. Always, we wanted to limit the number of control stages to a minimum in order to minimize the stages. So we decided, okay, let's look at what the satellites right now are capable to do. If you look at any satellite, small satellites in this sense, they would be able to do within 1.5 degrees of control stability. So we decided to look at that aspect. So satellite can roughly point within that, And then our systems, if let's say I don't have a very precise precision pointing, I still need the beam to be as much diverse as 1.5 degree, to which obviously increases the power for me to do that. Then we decided to implement a very fine pointing system, dedicated, which we indigenize with a certain components already put in place. So that enables us to put higher bandwidth in a very smaller form factor. The other challenge also is the link acquisition. In most of the time when we talk about optical communication that has been tested, you will see in at the back end there's always an RF link used for an initial acquisition, because you have to establish the precision position of the satellite where it was, and the ground station, and then you have to finally track it. So those are the certain challenges we want to minimize that part as well. So we sort of started doing with autonomous acquisition approach, where ground station without any RF communication network or as a priority to that can still communicate and establish optical communication with our satellite. So, so yeah, it was a difficult task, but we have to look at what's available in the market, what they can do, and build the technology around it that supports optical.
And one of the aspects of all of this is, of course, you need to find backers to you to mature this technology. And this is definitely not something very simple to mature as a technology. It needs a lot of engineering and a lot of hacking into different things to test everything out and,
Right,
to build it up. So, of course, one of the challenges has been for many of the companies, although you are a, let's say, much more older company in terms of all the young companies that are coming up today. I'm sure that you had your own set of challenges in raising money, finding backers, to doing all of this. So how was Astrogate able to get traction in terms of investment and to mature the technology itself?
right. Yeah, so funding has always been a challenge, especially when we talk about deep tech companies that requires multiple stages in which you mature the technology and further go to market. I see that this is now opening up. If you see the last 1 to 2 years, there's significant funding that has gone into space technology companies. When we started in roughly fall of 2017, uh, for us the major challenges was to get to at least a prototype one stage so that we can go and raise an early round. So we decided first to bootstrap it, and in terms of development also there was one challenge, like you need to have at least a lab to start testing out these. There are obviously incubator farms and all that provided, but our major challenge that came out to be is we wanted to have a communication that can do almost 1 Gbps, and most of the labs are not equipped to handle that sort of a signal rate. So we set up a small lab. We bootstrapped the company for almost for almost 8 months, where we early on finished our whole concept of the fine uh, steering and acquisition system. Then back we raised from friends and family, extended colleagues who were in the space technology sector, and we know from word of mouth, and they also know us about what we are doing. We also got an early DST grant. That was another way to actually raise early fund that we can get. This was actually to develop this terminal much further and uh, show that a prototype terminal can actually communicate over a scale distance. So that also got us to certain runway in by end of 2018. Roughly around Q3 2018, we started looking early fund for further maturing the terminal and developing the flight terminal itself. And that was, I would say, a long, perilous journey for us. It quite a time, almost 9 months for us to close this round, having talked to over 35 VCs and then angel investors. Post that, I think we are very much happy that we closed that round, and the support that we got and the conviction that we are receiving from our investors right now has pushed us much further to mature the technology and at this stage we are just looking at flying the terminal. So we are already at a TRL 7 for our flight terminal.
And what about, getting help from local, scientists or experienced folk? Was there any interest or even, for example, their own experience relevant for you guys? Because I have definitely seen many of the other startups like, maybe Bellatrix or Pixel or others who have, gone on to
Right.
leverage some of the knowledge that some of the scientists in ISRO or DRDO have had because they're just developing the next phase of this technology for small satellites for thrusters and so on. But in your case, you are developing something entirely new, and I don't think there is any division within ISRO or so on that is actually working on any optical related stuff. Correct me if I'm wrong, but what was
Right.
your kind of challenge in getting help or support from outside anyone?
Yeah, so mostly the help and support we got from our mentors as well. There was a series of ISRO mentors, and then a bunch of overseas. I have been interacting to multiple organizations in the past during my uh, during my previous work at TI. So I was able to bounce out certain queries. Yeah, one of the challenges was no one was dedicatedly working into optical communications. So no one can actually tell us what they are doing and how to solve that whole optical communication challenge. So, but we were able to break down that problem and actually look for dedicated experts for separate things. So we looked at, okay, this is a control system that I want to build. Can I build that or not? And there was actually advisors who and mentors early on that help us in that regard, both from Axistro background at PISA, as well as people who have worked in building early companies out. So they all assisted us in establishing this out, and actually some of them are still continuing to mentor us in that regard. So the challenge was basically we have to broke down that whole problem into, okay, I don't, you cannot tell us more about the optical communication, but at least, okay, this is the control system I want to build, and whether what would be the best way to test it out. And finally, on the let's say on the electronics one side, when we are actually building boards that are high frequencies, you need to do 1.1 Gbps and beyond modulation data rates. How do I build that out? What should be the constraints and all that? So that way it helped us. Obviously, it took certain trials for us to get to that stage uh, in terms of prototyping each of the subsystem and testing that out. But yeah,
So there are, of course, a lot of core components and technologies within optical communication systems, including the transmitter that have to do with, let's say, the source of light, or as you said, modulators and pointing systems and all of these things, and including also the ground segment of all of this. And one of the
right.
challenges in India is that you almost have nobody who is able to supply a lot of these things at the component level, almost, because most of the Indian suppliers are concerned mostly in build to print and manufacturing of electronic boards and things like that. So was there a lot of challenges in terms of identifying components, vendors, procuring them to then test everything together?
Yeah, in terms, you are right actually. In if we talk about all related to optical systems, there are no Indian manufacturers or vendor who does that. In fact, what we need is lasers and sensors, and then obviously the IC industry has much to do about it. And owing to the limitation of the suppliers, we were obviously looking much more outside. The other challenge is obviously we have to limit our component vendors to non-ITER. That's the way that we wanted to build out the system, not to go into the dual use application of this, at least when we are building out the prototype terminals and across. Uh, so we look at multiple vendors, mostly from the European ecosystem. In fact, the components that we are procuring currently now is mostly from Europe, and these mostly range from lasers, which cannot be procured here. There's no vendors available right now. Then there are electro-optical sensors, the receiver basically, which just converts that light into an electrical signal. Those sort of things. the major components, we have to look at suppliers outside. There was initial challenges owing, uh, you know, an early stage company. So there's also a perspective view that they have, like what you would be using it in which applications and all. It took time for us to get that stage, but finally that got resolved with the suppliers we have in the European ecosystem.
And what about the ground segment as well? Because you have the transmitter that you are building together. How do you, mature the ground system technology, or are you also partnering with somebody to work with you in that sense?
So on the ground system side, majorly again we are building the whole system out. The component on the component one side, mostly the ground system you can look at as optical communication ground station is basically one telescope then fit on the back end with multiple electronics and control systems in it. Since this we already tested out for a flight terminal, we know that the back end and all that we can build out. The telescopes was the major thing that we were looking at suppliers both from an Indian ecosystem and outside who can provide us that. And we also looked as commercial of the self telescopes in that sense. We wanted to comply as to get a technology which can be easily uh, made up with these components also and reduce the cost for the whole optical ground. So there, one of the challenges was basically on the cost one side, I need to know the whole optical parameters and of the telescope system, and that's normally no vendor will provide you. So we then finally decided to uh, try out with COTS, I mean a build to order telescope terminal as well, but that was also having a severe complications in that regard for an early test. Finally, as such, what we are doing is the telescopes are built by our partners. We take that telescope, the whole electronics and all final backend stack and everything is built by us. And then finally, then there is always a telescope mount as well, which provides rough corresponding assembly. Those are also built by our partner. The whole integration and the backend fine post precision systems and all that.
Right. And one of the aspects of all of this is how do you actually test it in space to make sure everything works in that sense, and you could also simulate some of those tests on the ground. How different is it to test these things on the ground, and then how different is it when it is on a satellite, when it is moving at 7 kilometers per second or so on? So how do you make sure that the text that you conduct on the ground can simulate like space environment in terms of the link distance and everything else as well?
Right. So what we normally do in scale test, obviously, the terminal that we are building is for 1,000 kilometer link distance from a satellite, and on a terrestrial one case, I cannot get 1,000 kilometers. So we do multiple tests, starting with a lab where we basically test out the receiver on the expected power levels. So what is my expected power level from a beam that is traveling over 1,000 kilometers as it reaches the receiver? So we test out that system and see what was the receiver sensitivity and other things are. And similarly on the optical side, on the transmitter side as well, where how much of the data modulation I can adapt to for that link distance. Then finally, and this is again in a static sense, so we are looking at the terminals not moving, but obviously that's not a realistic case. So then we proceeded on to doing ground trials where there's one fixed receiver and the transmitter is moving around that. Those tests validated both the things. One is if I scale the distances and my power levels are also scaled up, then I know my receiver will work. As well as in terms of a slew rate, let's say satellites mostly are slewing uh, close to around 1 degrees to 2 degrees in a minute. That's lesser than that. So those sort of scale down test we have to conduct here outside with one terminal moving and one terminal fixed. Then finally wanted to see how it will perform if the terminal is put on a much more moving platform. We tested it out into quad rotor platforms early on where we put the transmitter. up on the quadruped stage, and the ground station was tracking it. Uh, those early tests validated our whole control system in the sense. And link range, obviously, you can only do scale tests. You can scale the power down and test it that this is working at that level and still able to decode all the data. That's how we validated it. One of the key things, other than that, is which you cannot test mostly at this link level, is how much is the atmospheric uh, effect adds to it. So that mostly does goes into the modeling of the thing and the simulation, which you know from already established tests that has been done on optical communication, atmospheric parameters. You can plug in and then you can see, okay, at these parameters it is going to work like that. So those are mostly in the simulation, and the first test that we will do will actually get us more numbers on those atmospherics as well, which can further let us tune the terminal much more precisely. That that's more or it. More or less.
Yeah, and also I did read that you guys have, I think, signed up with Momentous for the first technology demonstration, right?
Yeah, we signed this launch contract mid last year. So Momentus is providing us the launch for this on a SpaceX launch vehicle. This is coming up in December 21, and obviously we needed the ground station also. So one major help that we got early in 2019 was uh, after we developed the prototype and test, we were recognized on the India Innovation Growth Program Challenge. So that award we got, as well as we got into the Venture Catalyst Space Program in Australia. Australia actually is looking for multiple deep tech technologies, which is more aligned with the space one side, and they were looking for advanced communication RF. So that gave us a good opportunity to be tied into that ecosystem and get support from there. They were very helpful in that regard. Till now, we have actually collaborated with multiple universities. One of the things that we are doing with regard to this launch is collaboration with the University of Tasmania, which they are providing us a site to put our optical ground station. So that way, actually, we can test the whole thing, both the flight as well as ground station, and get flight heritage on both of them.
And how do you see this technology being adopted, in terms of customer base at this point of time? Do you foresee international customers as your first customers, or do you believe that, given that you are an Indian company and there is proximity to other Indian, startups that are also building satellites today, some of your first adopters will be within India?
So uh, on the market side, we actually established two or three things depending upon the laser links as well. One is on the space to ground side. We are mostly having certain early customers who are ready to test it out once we have flight heritage. These are overseas satellite constellation operators who are uh, flying up their first two satellites, in a sense. So that was one area. Other area, at least on the home ground, we have uh, opportunities and our early attraction in establishing these terminals for more high altitude platforms and other links. So that's one more area of engagement, at least on the Indian side of it. As of now, we see early adopters is mostly on the satellite one. Satellite constellation operators were ready to fly this once we have from a global standpoint right now. And then finally, there's a on the space to space communication side also we have early clients who are interested to test out if we build that.
Right. And when you talk to a lot of these customers that are out there as an Indian company, as an Indian entrepreneur as such, what is the perception as Indian technology or an Indian deep tech company that is working on a specific technology and a specific subsystem? Do you see that you have
Yeah.
certain advantages because, like, let's say ISRO has a very good reputation of being very reliable, or this that does that transfer to you, or are there any, like, let's say, drawbacks that saying that we need to rely more on American or Israeli or whatever European technology?
Yeah. Uh, so actually, to be honest, that sort of perception is still there, which is it's reducing. So a deep tech company building a product out from India uh, can be done. So that's always that risk. The, that's the thing we have felt, at least in our earlier talks. But we were more than happy to engage them on our developments, and that seems to change over time. Also, one of the things that they are actually looking from India is they know, okay, the whole ecosystem here exists with all the work that is done by ISRO and the earlier vendor ecosystem that has been developed. So there is the capability to develop certain systems, but whether it will meet the requirements of their satellites, because most of the vendor ecosystem, if you see, was mostly built to order components for ISRO, right? And they don't have much of a flight heritage. They can transfer that knowledge base to building certain systems, which is much more globally acceptable in that standardized uh, design and the form factor that is needed. And then the added benefit is what at least the overseas players saw in us is the ability to reduce the cost of our turbines. In fact, much of the optical communication adoption right now is limited by two things. One is there's a lack of product itself in the small satellite category if we talk about, and then there is the cost of these terminals and the ground. So something that can provide these high links on the optical link, but may be compatible to an RF cost. That's what they are looking for, and actually, we were very thrilled how this has turned out positive for us over the last 2 years.
And one of the touchy things also here, I've seen this multiple times on my own, in fact, as such as well, that when it comes to a lot of these technology, when you establish the technology, that the technology is good enough and it's comparable to any other part of the world as well. One of the things that people often come back and tell me is that, oh, you are an Indian company, so it should be like half the price or three times less price than a European company or an American company. Uh, do you see this mindset still going, where people can come back to you and say you have to give me this at half the price because you're an Indian company, or has the market really changed its mindset on all of this?
So actually, this mindset I've seen has changed. In fact, we didn't face much of this issue because maybe our cost was already onto that mark that they were expecting. Because most of the optical communication terminals right now, if you talk about highest clusters, at least a six digit number, and on the medium side is in upwards of $100,000. So we are at sub $100,000 category. That was very attractive uh, to the potential customers out there. Well, there was a bit of perception on how much readily the cost can be reduced in terms of a production variant, but I think that it can be handled at a later. So not much specifically that we got like you're an Indian customer and can provide us at a much lower cost. That didn't so much as happen.
And one of the interesting things here, of course, is the adoption by ISRO, perhaps, of your technology. And one of the challenges, of course, from what I see is from ISRO side, is that they often, you know, take a very long time to shift gears in terms of technologies within satellites. And even to this day, there is no, I think, green propulsion in some of these satellites, and they're still struggling to move forward with all electric satellites and things like that. So it's not very easy to get them to change designs to adopt new things when it comes to all of these subsystems and so on. So do you see any possibility for you to either serve ISRO requirements or DRDO requirements, and there's a real opportunity for you to get into their procurement system and serve those missions as well?
Right. So actually, we are in a very early stage in terms of the ISRO and DRDO engagement. We do have a certain interest from them. So it's a bit early for us to tell how this will go. Having said that, we have seen that it has turned around in a positive manner uh, since the first ISRO interaction and all we had roughly in 2018 to give us like what we are building and how does it pan out. So yeah, so those things has changed right now, as you can see, with the adoption of ISRO taking active steps in terms of supporting the startups and maturing the technology. How much it can be absorbed within the ISRO ecosystem and how much the technology can be there, I think at least for us, it's a bit early to tell.
And when it comes to, let's say, these current changes that are happening with the policy changes and everything else, that seems more towards satellite operator, or companies that want to build launch vehicles where they want to get access to launch pads and everything like that, to get access to ISRO facilities and to get clearances to do all of these tests and everything. Is there anything that you take away for yourself as a company in all of these current reforms?
Yeah, so one of the things is we are looking for uh, is maturing the technology much further. And early on, we were already talking to for like a launch opportunity that ISRO can provide us to mature our terminals further. As you know, the plans have mostly changed. We are now doing a dedicated satellite mission altogether. But within that ecosystem, how much ISRO can at least help us in if we talk about the integration one side, and obviously on the regulatory one side, and the frequency clearance and other for the satellite. Those are the takeaways that we have right now. In the longer term, we are also uh, looking forward to like having a ground station here in India. Our The first terminal is actually an experimental ground terminal that we're putting into Australia. But later on, we want to deploy multiple ground station across the globe, and uh, support from ISRO in this regard would be much useful for us. So those are some of the takeaways that we have as of now, and we see, I mean, things progressing in that manner.
Yeah, and in fact, one of the anecdotes here is I know actually a bunch of Indian companies working in deep tech and have produced some of these products on the defense side, and they actually did not really get initial traction from DRDO or so on, or any of these defense end users. And they were able to sell globally first and show the rollout of their products outside of India first, and then there was confidence in Indian system and the government establishments to procure that as an Indian product. So I think this is the trend that I see mostly happening, possibly with ISRO and DRDO with respect to space as well, where companies may be forced to get early customers from abroad first, from India, roll out their product and show that they have customers abroad, and then possibly it gets easier to sell it to ISRO and DRDO.
Yeah, that's actually correct. What you were mentioning is that sort of a mindset, I would say, is prevalent in a sense. If you are an Indian company and you can still sell certain products outside, that gives you much more credibility in order to get into the ecosystem early. Uh, I see maybe that will change over time. Can't really comment on that right now.
Yeah, and what kind of programs would you think would have benefited you? Apart from funding, almost funding is always something that everybody lacks and everybody struggles for, and everything else. But in your sense, given your journey for the last so many years, if there were some things that you think would be on your bucket list that would have helped you a lot, that has to do nothing with funding, but anything else, what would that be?
Yeah, so one of the thing is basically the sort of as I mentioned earlier, for one of the challenges for us was having to build out a small lab ourselves, because most of the incubation firms and all that doesn't support the amount of work or the type of work that we were doing. So the systems and all that really doesn't help how far that goes. And actually that time this was not too much prevalent as well on the space technology one side, how you can get much more mentorship, and actually how these systems are developed. So that sort of a ecosystem it would have uh, been much better, who can basically uh, people who are actively working within the ISRO and DRDO environment, they know what sort of technology. If that sort of framework is already worked, okay, the certain startup is already working on that, and we can provide them, okay, these are my bare sort of minimum requirements that we are looking at, and you can the startups can on their own develop that and get early mentorship from the likes of ISRO or DRDO. That would have expedited, I think, our development effort. Other things also, which I should have mentioned to you earlier, is if we talk about our system specifically, there's also much more of a precision manufacturing required in terms of lenses and their alignments and other stuff. And this ecosystem is not outside. These are mostly within the DRDO and environment. So early access to the lab and how actually a startup can use that would have been useful. But I think we are already way past that right now, and things have already changed. The ISRO is right now providing facilities for others as well, startups.
And what do you expect to test out of this first flight demonstrator? Is it that apart from establishing the link itself, do you want you and testing the data rates itself? Are you also looking at testing, what happens during cloud cover and some of those things?
Yeah, so we are evaluating it for the whole performance envelope for us. One of that is obviously we are acquiring the whole link autonomously with our ground station beacon acquisition system. That's sort of a system that we developed for this. Other than that, how much the performance degrades in terms of atmospherics. Uh, for an optical communication link, everyone knows the and almost the challenge is mostly cloud. But cloud, as we see, are this sort of challenge mostly come up in satellites that are much more closer to Earth. So if you can dynamically allocate ground stations within the vicinity, that provides you much more higher coverage. So we want to evaluate that option as well, how much of a zone coverage we can have for optical communication ground station, which areas actually can provide higher round the year uptime for optical communication ground stations.
And do you expect that you also will roll out a ground network around the world for all of this? Because at the end of the day, you need multiple stations around the world to be able to downlink data more quickly and, let's say, more frequently, given different passes and everything. So do you see yourself evolving towards being a, let's say, full solution provider, vertically integrating from being able to build both terminals and ground terminals, flight terminals and ground terminals, and also will have stations to provide a fully integrated solution at the end?
Yeah, that's our whole vision. Uh, that's our vision actually, to get it up for a full stack solution right from satellite one side to the downlink one area. Here, primarily, what we are looking on the downlink optical communication site is tying with overseas partners to deploy the ground station much more quicker. That's our prime strategy that we are going ahead with. And the terminals obviously is built by us.
Right. And one of the aspects here is, the cost of ground terminal running, not just the ground terminals themselves, right? So, for example, KSAT has a lot of these terminals or RF ground stations in Svalbard, very part of Greenland, for example, right? So, and definitely some of the challenges there is more just the access itself, providing electricity for it, going, sending technicians to maintain that ground segment. In fact, those are more expensive than the cost of the ground station itself over time, I suppose. So do you believe that if you have a lot of these terminals outside of India, there is a significant cost to not developing the ground station itself, but then running it actually?
Yeah, actually, one of the major cost of these ground stations is actually the running cost itself. But that also depends on the size of your antenna systems and all. So if you look up mostly, which is prevalent right now, S-band and UHF communications for just the bare bones telemetry and telecommand to the satellite. Those can be now readily deployed on any rooftop. So most of the systems that are being deployed these ground stations right now is for on telecommunication building rooftops and other. Because the power requirements are lower, you can readily deploy it within that scenario. Uh, for bigger optical ground stations, which I'm talking about 1 meter and all, it's already established. It does require that sort of a location, that sort of a power and these requirements. But our ground stations are much smaller. The power requirements are not that huge. So we are looking at areas where that can be readily deployed, how current the S-band or the UHF communications terminals are deployed readily. The bigger terminals obviously require much more, outside city areas, full-time power supply, and also location to a grid network there where they can have access to that high voltage power supplies. So in that way, we are able to do away with that. So the constraints of having these ground stations much more closer to that area goes away, which in turns obviously reduces the whole operational cost of this ground station, as well as makes it much more easier to deploy in multiple areas.
And what do you think about this when it comes to the kind of satellites that will actually fly some of these terminals? Because at the end of the day, you have most of the high data rate requirements to be either Earth observation satellites that are having video or very high resolution imagery or things like that, which need these things. And then is there also some of these communication satellites that need these high data rates, or is what is the niche within the satellite market for all of this?
So yeah, in terms of the communication, there are two areas. One is the space to ground and the space to space link. Talking specifically of the optical communication opportunities on the space to ground, right now, if you see uh, just the percentage of terminals that are sold for the smaller satellite class, which are doing uh, applications primarily in Earth observations and other. Roughly 10% of them, those satellites right now goes for a high speed link. Of that, some of the optical communication terminals are there, which are mostly technology demonstration missions. Then there is X-band, which is still prevalent, and then the KU band terminals, which as of now there are also limitation of these terminals for the nano satellite one area. We see that expanding because there is a need for high speed uh, downlink data. Most of the systems uh, that these satellite operators are coming from is they have a need to downlink much more data in a day. Any solution that can provide them a much faster downlinks and then can cover their whole data demand for a day, they are able to look at that on the space to ground side. So that's one of the area that we are uh, directly targeting with our first terminal. The other area, which is the bigger area in just supplying terminal sales to the satellites, is space to space links, primarily in global broadband use case. So if we talk about there are right now in development Starlink already on the beta phase. Then there are OneWeb and Project which are trying to catch up. They they know that space to space communications on laser just makes sense. You're saving a lot of cost there. Then there is an inherent advantage. If you look about the last January launch of the Starlink terminals, at least on the polar one side, they have for the most of the polar satellites they have used laser comm for space to space communication. And the reason they did it because is first is right now most of the ground station terminals uh, the Starlink constellations are putting up is they need one ground station in the satellite footprint, which are mostly right now on the US one region. So for each of the user terminals within the satellite footprint, you need one RF ground station. You can imagine the number of satellites and the number of ground stations also increases. So that cost benefit trade-off with having RF systems, with deploying multiple RF ground stations, uh, can be done away if low cost optical communications can be fit for satellites providing space to space link. So that's one of the reasons they're doing away, they're going forward with that is, but most of the terminals right now, the optical terminal cost is also high. So if there is a provision where we can reduce the cost of the optical communication terminal, it will match the cost of match. It will be lesser the cost of deploying multiple ground station for each satellite footprint. And then added technology advantage is the latency also reduces, where now you have to hop, if you put multiple RF ground station within the satellite footprint and then hop it again over on the terrestrial communication infrastructure back to that, it increases the latency. Uh, if you just put inter-satellite laser comm, then there's only one hop for any two satellites within that area. So there's an inherent technology advantage. The major limitation, as we see right now as we are studying this market, is uh, there's an inherent, satellite operators are doing that inherent cost to benefit study in this, where deploying, let's say, 10 RF ground stations is compatible with one laser communication terminal. That's one of the area that we see heavily increasing in the current ecosystem.
Yeah, and one of the, again, from the user side of all of this, like when I think about it, I wonder if the defense guys would actually be more interested in this than others, because you can correct me if I'm wrong, that there is possibly reduction of this beam width and the layer of encryption that they can get, and all of these probably give them a fairly better advantage than typical RF stuff.
Right. So actually, yeah, defense, there is some interest more in from the Indian side as well, and also globally for these terminals where they can be readily deployed on aircrafts to high altitude platforms. So that sort of interest is there, and defense, as you know, I mean, the cost is not too much of a concern. It's mostly how much it fits within their requirement. The major need, as they are seeing there, is uh, the inherent security these optical communication links can provide. Uh, in that scenario, they are looking at how this technology can be further matured, where you get much more higher reliable links, and in fact, the data rates also goes up to 10 Gbps and beyond.
And I also wanted to ask you, because I don't know much about quantum communications and how these qubits and everything work with respect to establishing links and quantum key distribution and things like that. Of course, quantum, you're again talking about lasers in some form or the other, uh, as I see it. Can you broadly explain, how is it different, all of this optical communication, and what is going on in the quantum communication world?
I would not be the right person to actually bridge that gap, because I don't think anyone, and most of the people doesn't relate to the quantum systems as of now. But yeah, the inherent similarities between two of them is the provision of an optical terminal itself. If you want to do quantum encryption, you still need an optical communications, one front end altogether to just establish that communication. That's what, if you see, some of the players already are doing that. Most from the uh, global space agencies and certain startups are already targeting that use cases. Um, as of now, and this is just our opinion, we don't see um, that market going up, at least in the short term for that area. And that's also, the access to that sort of a technology and all that is limited in a sense. It will require multiple test out to do that. I think the major, again, this mostly will come from a defense use case. Then optical communication terminal will come up front, and then the implementation of further encryption on the quantum encryption on top of can go with that. So I see mostly these going on the defense one areas right now. And then again, it depends on where these players are targeting from.
Right. And you have now signed your technology demonstration for the end of the year, and probably shipping out the final flight units and so on. And from what I've read on the public broadcasts as well, is that Vishesh and Specialis have backed you guys as one of the early investors as well in your seed round. Uh, to establish yourself in the market, you probably will need a lot more going in terms of funding, and then bridging to be able to produce multiple of these units to provide it to end users and customers. Are you facing any challenges in terms of talking to people and getting their confidence in terms of raising a Series A, or how is it going for you guys when it comes to like taking this to the next level when it comes to productionizing all of this technology?
So specifically on the funding side, yeah, we actually Spatial has supported us a lot. The conviction in us really drove us to get to this stage as well. One of the key things on raising the funds, basically from a deep tech or a space tech angle, is there's a lot of uh, investor education that is required, and that it takes time to build it. So in a sense, I would not say as a problem, but yeah, uh, since this is also an area which is an upcoming sector in India as well as, and Indian investors are at the moment not too much uh, don't have too much knowledge at least on this sector. So there's a lot of investor education that goes with that, and how when will the returns come and other things. So that takes up time, I would say. Uh, and one more aspect of that is how you have performed over the last 1 year, 2 years, what the we are building, how does it go further from that. It does take time, I would say, but I think the time this thing has already changed, at least to the people now that we are talking to a few folks. They are able to relate to the space technology sector already growing in with with the multiple companies like Bellatrix, Agnicool, Skyroot, and all that establishing in that sector. So that there's already a lot of work that has gone in, and I think the change is already here.
Right. So, final question, Nitish. We've talked for an hour. Thank you so much for taking the time for recording this episode with me. So, I'd love to know what you think is the future and the next, let's say, 3 to 5 year self for yourself as Astrogate, and also what you think would happen with, a lot of the other Indian startups and their engagement with ISRO and others.
So I will be a bit optimistic here. Uh, if that going by what has gone over in the last 9 months is so opening up to private ecosystem participation in this, and I think it will increase further from here on that regard. The companies already coming onto the space technology sector has an inherent advantage as of now to do something in the space technology or deep tech sector right from India, and then they can get support from ISRO or the RDO and the like. The venture community is also increasing in that regard. Now there is some form of capital available for companies working out in this area. Other is I think, and early on you will still need to go on certain grants and early stage capital. How you raise would probably be uh, much more important in how we are actually maturing the technology over the multiple stages of fundraise capital. For us specifically, we are looking forward in the next 5 years is just coming 2022 that we are able to complete this whole demonstration, get to deliver our early terminals to potential clients out there, establish starting with two optical communication ground station that we want to put up by mid 2022. That's our benchmark here. And then finally cater to the country specific needs in defense and on the so one side. In the whole way, we still want to mature much our technology and finally adopt the space to space communication. That's right.
Again, thank you very much, Nitish, for taking an hour. And I wish you all the best in your technology demonstration. And hopefully, in a year or so, we would come back and we can have you as a guest back to talk about all the things that went on with all of that. And it would be a very exciting time. Thanks again, and have a Have a great day ahead.
All right. Thank you, MP. It's always a pleasure talking to you, and it was a much more insightful talk. Right. Thank you.